We are counting down the 5 most impossible machine discoveries, discoveries that mainstream science still refuses to explain. From ancient materials that outperform modern engineering to mechanical feats and electrical devices that simply shouldn't exist, each entry shatters what we think we know about our technological past. But which ancient technology is the most unexplainable of all? Let's begin our investigation with number 5. The Pantheon's massive concrete dome has stood unbroken since 126 CE. Nearly 2,000 years of earthquakes, floods, and war have failed to bring it down. The secret to this impossible longevity lay hidden until 2023, when MIT researchers examined ancient Roman mortar under powerful microscopes. Instead of uniform concrete, they found scattered white fragments called limeclasts embedded throughout the mix. Chemical analysis revealed that these inclusions were not a flaw, but the result of a deliberate hot mixing process. When cracks formed, water would seep in and dissolve the limeclasts, triggering a reaction that recrystallized new minerals, sealing the fissure as if the structure could heal itself. Micro-CT scans and SEM images captured this self-healing at the microscopic level, confirming that Roman engineers had created a material with nanostructured healing properties. Yet no surviving Roman text describes the recipe or the process. The technique vanished for 1,800 years, lost to history until rediscovered by modern science. Mainstream explanations credit Roman empiricism and volcanic ash, but the physical evidence suggests something else entirely. How did ancient builders master a self-healing material that modern engineers still struggle to replicate? And why did this knowledge disappear? A single drill hole in the rose granite of Abusir tells a story that refuses to fit the script of ancient engineering. The cylinder, cut more than 4,500 years ago, measures a perfect circle, its inner walls polished to a glassy sheen, as if machined by modern equipment. Scanning electron microscopy and laser geometry data reveal a surface so smooth that the measured roughness falls below what copper and sand can achieve. The pressure required to bore such a hole is not trivial. Calculations demand a continuous force between 226 and 380 pounds, maintained with unwavering precision. This is far beyond what a human arm or even a team of laborers could deliver by hand. Replications using copper tubes and quartz sand, the standard explanation, fail every time. The resulting holes are rough, conical, and uneven, bearing none of the flawless cylindrical geometry found at Abusir. No spiral tool marks, no copper residue, no sand abrasion scars. The archaeological record yields no tools capable of delivering the necessary pressure or the mechanical control. Egypt's catalogs list only simple copper implements, worn and battered, never the robust machinery that these holes demand. Identical drill holes appear at multiple sites, standardized as if produced by a lost technology. Despite what mainstream science claims, the physical evidence suggests something else entirely. How did ancient Egyptians achieve machine-level drilling without leaving behind a single tool that fits the evidence? At Sacsayhuaman, stone blocks weighing over 100 tons locked together so precisely that a knife blade cannot slip between them. Knife tight. The largest stones rise 4 meters high, some spanning 5 meters in length, quarried from sites as far as 35 kilometers away. Each face meets its neighbor with sub-millimeter precision, not just on a handful of blocks, but across entire walls and terraces. Precision. The stone of choice, andesite, ranks near the top of the Mohs scale at hardness 7. Yet the only tools found at Inca archaeological sites are bronze chisels and stone hammers, neither capable of cutting or shaping andesite with this level of accuracy. Bronze, with a hardness of just 3, deforms long before it leaves a mark on these blocks. Physical evidence tells a story that resists easy explanation. Tool marks on the stones are uniform, as if produced by a standardized process, but there are no spiral cuts or rotary abrasions, no sign of the kind of sawing or grinding that would leave a mechanical signature. Evidence. In the 1970s, engineering teams set out to replicate these joints using only the tools available to the Inca. Hammerstones battered the surface, bronze chisels dulled and bent, and each attempt left gaps far wider than the originals. Not a single trial achieved the knife-tight fit seen at Machu Picchu or Ollantaytambo. The best efforts produced rough, irregular faces and joints that leaked light and dust, unable Mathematical studies of the walls reveal another layer. The interlocking shapes and zigzag seams distribute seismic forces, protecting the structures from earthquakes centuries before modern seismic engineering. See seismic. Despite what mainstream science claims, the physical evidence suggests something else entirely. How did the Incas, without iron tools or advanced machines, fit 100-ton stones with such perfection, and why does every attempt to replicate their methods fall short? In 1936, workers digging near Baghdad unearthed a clay jar sealed with bitumen, a copper cylinder inside, and an iron rod at its core. The artifact landed on the desk of Wilhelm Koenig, a museum curator who recognized the strange combination, not as a ritual vessel, but as a device. The measured voltage was unmistakable. Replicas filled with vinegar or grape juice generated a steady 0.5 to 0.7 volts each, enough when stacked to exceed 4 volts, a voltage any modern meter can measure. Laboratory tests powered tiny lights and even plated thin layers of metal onto coins, confirming the device's basic function as a battery. This was not an isolated find. Similar jars turned up at Seleucia and Ctesiphon, each built to the same specifications: a clay vessel, copper tube, iron core, and bitumen seal. The design always optimized contact between metals and electrolyte, maximizing electrical output. No two pieces are identical by accident. The pattern repeats with only minor variations, suggesting a standardized process rather than a one-off experiment. Despite this, mainstream archaeology resists the battery theory. Most experts argue these were storage jars or ritual objects, pointing to the absence of any written instructions or technical documentation. No ancient text describes electrochemical theory. No wall painting illustrates their use. The Mesopotamian record is silent on the purpose of these jars, leaving only the artifacts themselves and the voltmeters reading. Still, the evidence refuses to cooperate with conventional explanations. Residue analysis hints at acidic contents, but no papyrus, inscription, or manual survives to reveal intent. No electroplated artifacts have been found in direct association, and the jar's bitumen seals would have made repeated use cumbersome. Yet the physical fact remains. Mesopotamian craftspeople engineered functional batteries nearly 2,000 years before Volta, then left no trace of the underlying science. The mystery persists. How could a culture master electricity in practice but erase every record of its theory or application? A corroded mass pulled from a Mediterranean shipwreck in 1901 would force science to redraw the boundaries of ancient technology. Inside that lump, Greek archaeologist Spiridon Stias uncovered a lattice of bronze gears, delicate, interlocked, and impossibly precise. The Antikythera mechanism, as it became known, contains between 30 and 40 gears, each cut with tolerances so fine that modern CT scans measure the gap between teeth at less than 1/10 of a millimeter. Some gear wheels are engineered with prime-numbered teeth, 53, 127, 223, calibrated to track astronomical cycles that repeat only after centuries. This was not a simple calendar. The mechanism predicted solar and lunar eclipses, charted the positions of 5 known planets, and marked the dates of the Panhellenic Games, including the Olympics. The complexity rivals that of an 18th century Swiss watch, yet it predates the first European mechanical clocks by more than 1,000 years. Hidden inscriptions, over 1,200 ancient Greek words, cover its plates and dials. These texts, revealed by polynomial texture, mapping, and X-ray imaging, form a user's manual, complete with operational settings and astronomical theory. Deciphered lines describe how to set the device for a specific date, how to read the cycles of the moon, and how to interpret the predicted eclipses. Attempts to reconstruct the mechanism have pushed the limits of experimental archaeology. Modern teams, led by researchers like Tony Freeth, rely on CT scans and AI-driven gear mapping to piece together the shattered fragments. Each successful replica confirms the original sophistication, but also exposes the absence of any known tradition leading up to or following this device. No workshop debris, no matching tools, no intermediate prototypes have been found, only this one battered relic from the wreck. Mainstream scholars credit a lost Hellenistic school, perhaps rooted in Rhodes, but the physical evidence stands alone. The Antikythera mechanism represents mechanical computation at a level that should have been impossible for its time. What remains unexplained? How did ancient Greeks master such precision engineering, and why did this knowledge vanish for more than a millennium? Across all 5 discoveries, one truth emerges. Our timeline of technological progress is not a straight line, but a puzzle missing critical pieces. The precision, creativity, and lost knowledge suggest ancient civilizations reached heights we still struggle to explain. The real mystery is not what they built, it is what we are still missing.